Imagine a world without computers, smartphones, or even electricity. Hard to picture, isn't it? Well, thanks to solid-state physics, we don't have to. This branch of physics, which explores the properties of solid materials, is the unsung hero of our daily lives, underpinning many of the technological advancements we take for granted. Solid-state physics is a melting pot of several disciplines. It borrows ideas from quantum mechanics, crystallography, electromagnetism, and metallurgy to understand the properties of solids. Through experimental techniques like X-ray diffraction, electron microscopy, and spectroscopy, scientists probe the structure and properties of solid materials. Theoretical models based on quantum mechanics then help explain and predict these properties. Now, here's where it gets interesting. The arrangement of atoms in a solid, known as the crystal structure, plays a huge role in determining the material's properties. Similarly, the energy levels of electrons in a solid, grouped into what's known as the band structure, dictate whether the material is an insulator, conductor, or semiconductor. Even tiny imperfections in the crystal structure, called defects, can drastically change how a solid behaves. And some properties like superconductivity and magnetism emerge from the interactions of many particles within the solid. These principles help to explain some key properties of solids. Take electrical conductivity, for example. Metals with their freely moving electrons are excellent conductors, while insulators are poor conductors. Thermal conductivity, or the ability to conduct heat, also varies among materials, with metals again leading the pack. Solids also interact with light in different ways, leading to phenomena like reflection, refraction, and absorption. And then there's magnetism, with materials showing different types of magnetic behavior. Lastly, we have mechanical properties such as strength, elasticity, and ductility that describe how a material behaves under stress. So why does all this matter? Because it's the foundation of countless technological advancements. Transistors and integrated circuits, the building blocks of modern electronics, owe their existence to solid-state physics. So do semiconductors, which are used in everything from solar cells to light-emitting diodes. Superconductors, materials that conduct electricity with zero resistance, have applications in high-speed trains and medical imaging. And then there are nanomaterials with features on the nanoscale that promise to revolutionize fields like medicine, electronics, and energy. In summary, solid-state physics is a fascinating field that explores the world of solids. It combines various disciplines and methodologies to understand the properties of solids. Its key concepts include crystal structure, band structure, defects, and collective phenomena. It explains important properties like electrical and thermal conductivity, optical properties, magnetic properties, and mechanical properties. And it's at the heart of numerous technological advancements. So next time you use your smartphone or laptop, remember, you have solid-state physics to thank.